Hi there. The following video clip will show you how to rationalize the denominators of fractions with surds in them, in more complicated cases. Let's remind ourselves what rationalizing was. Imagine I had a surd on the bottom of a fraction, for example, 1 divided by root 3. The root 3 on the bottom makes a mathematician unhappy, so he thinks, or she thinks, what can I multiply the top and bottom by to remove the root 3? Well, if I multiply the top by root 3 and the bottom by root 3, I would get 1 times root 3 is root 3, and then root 3 times root 3 is root 9, or 3. I've created an equivalent fraction to 1 over root 3, where the square root, or the surd, is no longer on the denominator, but it's on the numerator. Okay, here's a more complicated example. The difference here is you don't simply have a surd, you've got some form of addition on the bottom, or subtraction as well. So you might say to me, well, if we multiply the top and bottom by root 3 again, because after all the root 3 is what's causing the mathematician his unhappiness, let's see what happens. 1 times root 3 is root 3, and we would have on bottom 2 plus root 3. All of that has to be times by root 3. Well, on the top, the root 3 stays. Open up the brackets, or expand the brackets. 2 times root 3 is 2 root 3. Root 3 times root 3 is root 9, or 3, so add 3. Unfortunately, the root 3, the square root of 3, is still on the bottom, and the mathematician remains unhappy. I have to think of something else to multiply the numerator and denominator by to remove this surd. If you think back to a previous video where I showed you the difference of two squares, you might say to me, imagine I multiplied the numerator by 2 minus root 3 and the denominator by 2 minus root 3. What would I get? Well, 1 multiplied by 2 minus root 3 is simply 2 minus root 3. On the bottom, you're multiplying together 2 plus root 3 and 2 minus root 3. Well, think back to the difference of two squares. If ever you have two brackets where inside the brackets are the same numbers or expressions, but in one of them it's an add and in another one it's a subtract, the answer is always the first term or number squared subtract the second term or number squared. We seem to have this on the bottom now. A plus b multiplied by a minus b. 2 plus root 3 multiplied by 2 minus root 3. Therefore on the top we still have 2 minus root 3, but on the bottom, well, we have the first number squared, 2 squared, subtract root 3 squared. Well, 2 minus root 3 still remains. 2 squared is 4. Root 3 squared is 3, so you end up with 4 take away 3, which is 1. This simplifies to 2 minus root 3 over 1, but a mathematician would probably write that as simply 2 minus root 3. Okay, moving on to the next slide, I will show you another few examples. I should use the difference of two squares rule here and multiply. We've got a 4 minus root 5 here, so to use the difference of two squares I need to multiply the numerator by 4 plus root 5, and similarly I must do the same thing to the numerator. 5 times 4 plus root 5 all over, well, a minus b times a plus b. The first number squared is 16, subtract root 5 squared is simply 5. On the bottom, 16 take away 5 is 11. 5 times 4 is 20. 5 times root 5 is plus 5 root 5. I've generated an equivalent fraction here, and the surd is no longer on the bottom. I will just tell you what you need to times the top and bottom by in these two examples and leave it to you. Multiply the top and bottom by root 10 plus 1, root 10 plus 1. Multiply the top and bottom here by root 7 plus 2, and root 7 plus 2. And you should be able to do those now and get the rationalised fraction.